Remember folks, don't try any of my experiments and demonstrations at home without parental supervision.
Unless you are an adult.
Unless of course you are an adult. Today, I'm not just playing with fire, because we don't play with fire, okay? But this is some methanol. Methanol is a type of alcohol. It is flammable, but it's an alcohol burner. But I'm going to use that because I want to do something. Check this out. This is an aluminum pipe. It's pretty heavy. Aluminum rod.
Listen to me, you have to pump up when you do this with your rods, you listen to me. I'm cutting it out, okay? Pump it. I put things down and I lift them up. I put things down and
Okay, here we are going to, I want to see what happens if you just we talked about heat and how it needs conductors. A good conductor of heat is metal. So what happens is metal basically warms up, right? And then it travels right through the molecules. But I want to see if there's some kind of reaction that occurs just by heating a rod. Well, that was a good amount of time. By the way, these sounds are not being dubbed over the internet. This is not special effects. These are actual sounds coming out of this heated pipe. So we're talking about the conductivity or the conductors of heat, okay, and metal being one of them. And we talked about something called sound. We all agreed that sound was the vibration of what?
Air molecules.
Air molecules. I like the way you said that. Air molecules, okay? And those air molecules will travel at a certain speed. Depending on the speed is what you're going to hear. A low speed, you're going to hear what? A slow speed, you're going to hear a low sound, is what I meant to say. A very fast, high, frequent motion, what are you going to get?
A high sound.
You're going to get a very high-pitched sound. So what we're doing is we're speeding up molecules today. We're speeding up air molecules inside a metal tube. Heating up those air molecules, we're going to get the sound we're looking for. And we'll see how fast heat actually makes molecules go. It's the same pipe. Metal pipe, we're trying to get those air molecules flowing. Maybe I can dump the air out. Dump the sound out. So why is this happening? Why on earth is that sound going through the tube? But could this happen with any old empty pipe? This is no ordinary pipe, folks. I was heating up the sides of this only, right? If I was heating up the sides of this, would you get enough air to come through? Enough heat?
No.
No, because the heat would stay in the metal tube. There's something underneath this pipe that is actually trapping the air. You're seeing a screen, a meshed screen. Okay, there's a mesh screen in there. That screen is heating up. You're heating up these small little holes, and the air is traveling at a very fast rate. You're going to get your high pitch. And then you can have fun with it, and I can pretend that I'm pouring the sound out. So you're getting that? I send it back up, and now, so good. That's exact. So that's the same pipe. Remember, folks, don't try any of my demonstrations at home without adult supervision.
Unless you are an adult.
Unless you're an adult.